Patty Simpson with Simpson Math. Let's solve some equations with fractions. So here's an equation that has 2/3 times some number is going to equal 4/3. And we want to solve this equation. My favorite method for solving equations with fractions is to find a number to multiply both sides of my equation by that will make the fractions go away. And if we find that least common denominator of our fractions, that's going to be the number that we can multiply both sides of my equation by that's going to make that happen. So in this case, both of my fractions have a 3 in the denominator. So I'm going to multiply both sides of my equation by 3. Remember, I have to multiply by the same number on both sides of my equation. So I'm going to choose the number 3 to multiply by. And the reason I'm multiplying by 3 is because my denominator is 3. Remember, when you multiply by a number, there's really like a little 1 on the denominator here. I multiply top times top and bottom times bottom. Well, 3 times 1 would just be 3. And notice what happens. This 3 times that 3 is going to make it 1. So I could have just right here said this is going to be 1, and it leaves me with 2x. On the other side, the same thing's happening. There's really a 1 in the denominator, so 4 times 3 would be in my numerator, and 3 times 1 is in my denominator. And this 3 and that 3 become 1 again, and so it leaves me with 4. Notice by multiplying both sides by that number, it got rid of my fractions. Now I don't have to worry about the fractions to deal with. And now I can just solve this equation like I normally would. So I can divide both sides by 2 and find out that my x is just equal to 2. If I just multiply here by 2, I would get 4/3. Let's solve some more equations with this same strategy in mind. So let's do 2/5 x plus 4/5 equals a negative 2/5. So I'm going to multiply both sides of my equation by one number, by the same number, to get rid of my fractions. And the way I'm going to choose that number to multiply both sides of my equation by is I'm going to look at the denominator. And in this case, my denominators for all of my fractions are 5. So I'm just going to multiply both sides by that 5. I'm going to multiply the left by 5, and I'm going to multiply the right by 5. Now on the left, I have 2 different terms here. I have to distribute this 5 to both of those terms. I'm going to multiply each item on that side by 5. So I have the 5 times the 2/5 x plus 5 times that 4/5. And then on the right, I'm multiplying by that 5 as well. We could go ahead and do on the right, this 5 divided by that 5 is going to be 1. So I'm going to be left with just negative 2 there on the right. On the left, this 5 divided by that 5 becomes 1, and I'm left with 2x. This 5 divided by that 5 becomes 1, and I'm left with just the 4. So when I choose 5 to multiply both sides by, which I can do in an equation as long as I keep it balanced, I can multiply both sides by the same number, then those 5s make that 1, and then it just leaves me with the numerator times my variable there. Now I can solve this equation like I normally would. I subtract 4 from both sides to leave me with 2x equals a negative 6. And then I divide by 2 so that x is equal to negative 3. If we multiply this times negative 3 to begin with, then these two sides of my equation would be true. My x value is equal to negative 3 to make that equation true. Let's do another example. Here I have 2 times the quantity x plus 1, all divided by 4. And that's equal to 3x minus 2. In this problem, only one fraction exists. But if I multiply both sides by this 4, it's going to take care of that fraction for me. So I need to multiply this side by 4, and I need to multiply this side by 4. Now, when I multiply this side by 4, this 4 divided by that 4 becomes 1. And 1 then times my numerator is just that numerator. So by multiplying both sides by that 4, I took care of that fraction. On the right, I need to make sure that I distribute that 4 to each term on that side of the equation. So that I have 12x minus 8. Notice the difference. On this side, it was all one big term. So this 4, because of this vinculum here, this 4 divided by that 4 made 1. And it left me with the numerator. But here I have 2 different terms. There's nothing that connects them. There's no grouping. So I need to multiply that times both parts. Now I'm going to solve this equation like I normally would. I simplify on both sides first, so that I have 2x plus 2 equals 12x minus 8. And then I need to get my x's on the same side of my equation. So I can either move those 2 x's over here or move those 12 x's over there. We'll just move our 12 x's by subtracting out 12 x's. Whatever I do on one side, I have to do on the other. You could do it the other way too, whichever one you like best. Maybe you prefer to subtract the 2x so you end up with a positive number out front. Whereas doing it this way, we end up with a negative number out front. Either way works. Now I'm going to subtract 2 from both sides, getting my x value isolated, negative 10. And then I just divide both sides by negative 10. So once I get rid of that fraction, then I'm just solving the equation like I normally would solve equations. The difficult part is dealing with the fraction. So let's do another example. Let's look at x plus 7/6 equals 2x minus 7/3. Again, I'm looking at the fractions and I want to multiply both sides by the same number so that we can get rid of our fractions. In this case though, my denominator is not the same on both sides. So I'm going to look for the least common denominator, the thing that both 3 and 6 go into. And remember, in your least common denominator, it has to be at least as large as your largest number. So it has to be at least 6. And it turns out that 6 goes into 6, and 3 goes into 6. So we can use 6 as our least common denominator. So I'm going to choose 6 to multiply both sides of the equation by, since it is our least common denominator. When I multiply both sides of the equation by that number, I'm really multiplying the 6 times the x, and I'm multiplying that 6 times the 7/6. On the right, the same thing's true. I'm multiplying this 6 times the 2x, and I'm multiplying that 6 times the 7/3. So 6 times x is just 6x. This 6 divided by that 6 becomes 1. So it just leaves me with plus 7. On the right, 6 times 2 is 12, or 6 times 2x is 12x. On this one, since this number is not the same as that, I can't just make them 1. But I can still do that division. 6 divided by 3 is 2. And here's why I can do that. Remember when I'm multiplying fractions, that what happens is on top, I'm going to multiply this 6 times the 7, and on bottom, I'm going to multiply the 3 times the 1 that's on bottom there to get 3. Well, before I do this multiplication, notice that this 6 divided by that 3 is 2. So I really end up with 2 times 7 there, or 14. So my equation looks like this. 6x plus 7 is equal to 12x minus 14. So this 6 divided by 3 became 2. 2 times 7 gave me that 14. Now I'm going to solve my equation just like I normally would. There's nothing to simplify on either side of the equation, but I can get my x values on the same side. So last time I moved from left to right, this time we'll move from right to left. This time I'll move from left to right. It doesn't matter which way you do it. You can either subtract 12x from both sides, or you can subtract 6x. But I need those x's on the same side. So this zeroes out, and it leaves me with 0 plus 7 is 7. And on the right, 12x minus 6x is 6x minus 14. Now, whatever's not touching my x, I'm going to get rid of next. Inverse of subtraction is addition, so I'm going to add 14 to both sides. That leaves me with 21 equals 6x. Now I need to divide both sides by 6. So then my x value, this becomes 1, so my x value is equal to 21/6. I can reduce that. 3 goes into 21 7 times, and 3 goes into 6 2 times. So x is equal to 21/6, but 21/6 is the same as 7/2. 21/6 divided by a fancy 1 there of 3 over 3 is equal to 7/2. So if I put 7/2 back in here for x, it would make both of those sides of the equation true. All right, one more. So when we are dealing with fractions and an equation, since we have an equation and an equal sign, we can just multiply both sides of our equation by the same number to get rid of our fractions. Here I have 2 and 5 in the denominator, so I need to find my least common denominator, the number that both of these go into. Well, neither one of those have a common factor, so I can just multiply those together, and 10 is my least common denominator, or least common number multiple that those two go into. 2 goes into 10, and 5 goes into 10. So I'm going to multiply each part by the 10. So 10 times x over 2, or x halves, minus 10 times 1 is just 10. And then on the right, I have 10 times x over 5, or x fifths, plus 2 times 10 is just 20. So I distribute that to each of those. And when I do that, this 10 divided by that 2 becomes 5. That's equal to 5. So it leaves me with 5x. And here, this 10 divided by that 5 is equal to 2. So that makes 2 times x is 2x. Now I'm just going to solve the equation like I normally would. I'll move these x's over, so I subtract 2x from both sides. That leaves me with 3x minus 10 equals 20. Add 10 to both sides. So that I end up with 3x plus 0, which is just 3x, equals 30. Divide both sides by 3. And x equals 10. So 10 would be the number I could put in here for x. That would make both sides of the equation true. 10 divided by 2 is 5. 5 minus 1 is 4. 10 divided by 5 is 2. 2 plus 2 is 4. 4 equals 4. So it would make that equation true. So when we are solving equations with fractions, if we just multiply both sides of the equation by the same number, and we choose that number to be the least common denominator of our fractions just go away, and then we can just solve the equation like we normally would. Math made simple at Simpson Math. Thanks for watching.